All right. So, what most of this unit is going to be about is the connections between magnetism and electricity. And the first connection is that there's going to be a force on a moving charge. A charge moving in a magnetic field will experience a force. Now, this force is really weird, okay, because there are some things about the force. The charge must be moving. So if it's moving in the magnetic field, there's going to be a force, but if it's not moving, there is no force. Okay. The motion of the charge must be at an angle to the magnetic field. So if it's parallel, there's no force. But if it's moving perpendicular, that's when you get the maximum force. And the force, and we're going to deal with this more later, is perpendicular to the motion and magnetic field. So, so that's kind of weird. That would be like if the magnetic field, you don't have to draw this, but I just wanted to see it one time. If the magnetic field is this way and the charge is moving this way, there would be no force. Okay, but if the charge was moving this way, now there's going to be a force, and it's going to be maximum because it's a 90-degree angle. That's the biggest I can get. And the direction of the force would be weird. What's perpendicular to both right and down? The only things that are perpendicular to both of those are coming up out of the page and going down into the page. So the force would be into the page or out of the page. So something is moving down toward the bottom of the page. The field is going to the right, and yet the charge gets pushed down into the page or up out of the page. So it's a very strange force. And the equation for it is going to be F equals Q V B sine theta. All right. Q is charge. We should remember that. V is velocity. B is magnetic field. And theta is the angle between V and B. So our first example of this is right here. All right. I have a proton, a neutron, an electron in the electric field. Sorry, it should be a magnetic field. Of 2 Tesla, I give you the velocity there. Okay, so we'll do the proton first. Charge on a proton, we should remember, is 1.6 times 10 to the minus 19th coulombs. We're given that V is equal to 4 times 10 to the 6th meters per second. Given that the magnetic field strength is 2 Tesla right here. And our theta is going to be 90 degrees in this case because this velocity is to the right. And if we remember, the x's mean into the page. And those are going to be at right angles to each other. Okay, going to the right and going down into the page, those are at right angles to each other. Whenever theta is 90, sine theta is going to equal 1 then I can leave it out of the equation. So now I'm going to do F equals QVB sine theta, and I can ignore the sine theta because the theta is 90 degrees. And I'm going to get 1.6 times 10 to the minus 19th times V was 4 times 10 to the 6th. And the magnetic field is 2. And when I solve that, I'm going to get a value